We're going to talk about different technology modules we have produced here in our little presentations. So, first off, we have military technology, and the second off, we have 2 times robotic technology. First off, we're going to talk about something called FCS, which is a shortcut for Fire Control System. It's a system that sits in most armored vehicles like tanks and IFVs, like this one here. The thing about FCS is that it's a program you use to aim your projectiles. It's a computer system. You tell wind temperatures, humidity, propellant temperatures, wind speed and directions and so on. And when you do laser range finding, the computer can calculate exactly where the barrels are going to be to hit a target out of a certain distance. The big innovative part about this system is that you can achieve an extreme precision with your weapons. You can easily hit a target up to 5 kilometers away when you are using such systems, which has made major improvements in the capabilities in armored vehicles. Furthermore, you can hit moving targets also at the same distance, also even when you're moving yourself, going on the rough terrain. And second of all, you can use programmable ammo, which is the system we have here on a system that programs ammunition to detonate at a certain distance out when it's supposed to hit the target. This technology is built up as most military technology. It's built up in modules and often comes in packed solutions, which we are going to go a little further into. Some of the characteristics about the systems is, as also with many other military systems, is extremely pricey. For this particular vehicle here we have, it's roughly 85% of the development money that was spent into it was on this particular system. Another characteristic about it is its ongoing updating, which is where module build-up comes. So when new technology comes, you simply just change out that one module at a time. So you slowly keep upgrading your vehicles. Because again, these vehicles are generally very expensive, and they're also made to have a very, very long service time. Furthermore, when you do these military contracts, there's a huge amount of paperwork involved in agreements from the factory about how to maintain and use and upgrade, and from the military of what the capabilities are supposed to be of the entire system. So that's where this module build-up comes in. It's supposed to last long. It's supposed to be slowly upgraded as the military found money for upgrades as it comes along. And just to short sum up, the system was a very efficient system when it was introduced into the modern vehicles. It's very, very expensive. It has a long service life, and it's built up amongst a lot of agreements and restrictions about how to use and not to use. And that was basically my turn for this module.
Okay, so I'm going to talk about cobots. First of all, one misconception: cobots are not actually like normal robots. They are intended to physically collide with humans and work with them. So here I list some of the advantages for cobots. As you can see, they're easy to program, easy to set up, flexible and safe. What does this mean? Easy to program means that they have like really different ways to be programmed, allowing inexpert people to actually program them and change their functions as they go, allowing for a wide variety of people that are not prepared for programming like industrial robots that need a lot of parameters, be able to program this kind of robots because they're much easier and has more security than common robots. Easy to set up. Most of these cobots, they don't need to be placed in a specific way for creating the environment for the robot to work. You just need to deploy them whenever you need them, and you can adjust everything by hand or by controlling them with the different programations they can be done. They are also flexible. They can fit in a lot of tasks. You just have to change maybe some of the parts repurpose them several times to make them fit different needs and different purposes. And safe. These robots are mainly done for working with people, so they are always filled up with different kinds of sensors and cameras to detect people and to make sure no one collides with them. Some common questions regarding cobots and how they work. First of all, what happens with the old tech that they replace? What usually happens with these kind of technologies are they are sold to another companies or from other developing countries that they can use that kind of technology, even if it's a little dated, is fine for them. They don't need that kind of power. Also, what characterizes long-use technologies? Well, cobots is been done to be going to be a long-use technology, and a lot of people ask why. So people should know that these technologies are reliable, easy to manage, easy to use, and this allows different companies and people to work with them in a lot of terms, which make them easy to work for longer times than normal technologies. For example, several of the industrial bigger robots that are right now in the market, they will be standalone technologies, but some of the robots that are for other mundane tasks will be used as cobots. And also, another big question, and usually a misconception, is does it destroy human jobs? No, it doesn't. It actually sometimes even creates more jobs, because if someone is, the cobots do not operate by themselves, they don't have to, but they can be used with humans, so people just have to adapt to be working with a robot, not with another human. Also, as it's really easy to program, most of the people that are going to be replaced with a robot, they can just be, they can just start programming that robot in particular. How are they used right now? Right now, the most popular way to program them is using hand guiding. A really difficult task, for example, would be like getting to a small frame and move things over there, which programming that with a normal industrial robot will be hell, because it would take several days of programming. But for example, with this kind of robot, you could just move the hand to the position you want and select the task you want to do, and that would be pretty much it. Power and force linking, the same thing. If you want to do something more delicate, you have to adjust it and do several tries with a normal robot. But using a cobot, you could just select the grip or the grasp and just place it in the exact position and strength. Safe monitor stop. This would be, for example, in case it collides with a human, or not even has to be a human. It can be, for example, another robot or a piece of equipment. The robot can stop itself immediately, and it can even go backwards. Speed and separation monitoring. You can monitor the speed and the separation between it and other objects remotely. So you could be allowed to, if you want to work faster, you could do it, but if you need really slow to have a lot of precision, you could do it too. Where can you see these kind of robots? First of all, these robots are implemented in a lot of factories right now, but the most important ones could be, for example, the Ford Fiesta plant, the Amazon Fulfillment Center, and the Ocado online supermarket. Then, for example, new companies where you could see them, they are implementing it for smaller tasks like assembling electronics, or for example, holding big pieces of material that they need to be assembled by a human actuator, but they don't necessarily need another robot to make that task, because it won't be as efficient as it should.
And now we are going to talk more about robots for medical purposes. In our field trip with class, we've been in Odense, and the most interesting technology what I found with my classmates was robots from Blue Ocean. Each year, approximately like 50,000 Danes are catch with the infection during the hospitalization, and about 3,000 people are dying after all. It costs a lot of money, of course, but it's a really good innovation for hospitals. Blue Ocean, robots for the medical use. This robot is used for operations room, such as operation with stomach, bones, elbows, or even burns. It's a very precise robot, which means that it moves by himself, charging by himself, and also it's very safety. So, of course, nobody can be in that room when the robot is working, but if that happens, he will immediately stop. The robot using UV lights to destroy all of the bacteria which are in the operation rooms, and he also destroyed approximately 99.9% of the bacteria, so the room can be clear and ready for the other operations. This is everything for us. Thanks for the attention, and if you have any questions, please ask.